Let's look at an example where we use StatCrunch to calculate the p-value for an hypothesis test from two samples. We're looking here, a restaurant owner is interested in whether or not a menu change would change her customer's opinion of her restaurant, more specifically their satisfaction of the restaurant. To test this, the owner decided to take a sample of 350 customers before the menu change and after the menu change and gave them a survey to rate their satisfaction, and that's on a scale of 1 to 10. We have the results below, and we want to test the claim that the menu change resulted in a change in customer satisfaction. We can think of that as there was a difference between the mean scores, the mean satisfaction scores. So in this example, similar to when we calculated a p-value and to see two sample proportions, we want to make sure to label what we know. So we're going to call, in this particular example here, we're going to call the menu before the change. We're going to call this grouping 1, and we're going to use mu1 to represent the population mean associated with this sample. And then over here, we're going to associate the after the change. This is the second sample. We're going to use mu2 to represent the mean score after. So what we want to look at is whether or not there is a difference between the means. The claim is that, actually, I guess she wants to know whether or not there is a difference. So we don't really necessarily have a claim. She's not saying that there is or isn't. But we know when we write the null and the alternative hypothesis, the null hypothesis, we just assume that there is no difference. There's no difference between the means, which we know if we were to subtract the means, the difference literally in terms of subtraction is equal to 0. So here is one way that we'll see it written in terms of a subtraction problem, and the other way is using just mu1 equal to mu2. Now we're not testing whether or not, and we can see the sample mean after increased, right? The satisfaction level increased. We're not looking to see whether or not people are happier. We want to know if there's any difference. So that is telling me that our alternative is that we're just looking for whether or not there is a difference. mu1, the satisfaction before, is not equal to the satisfaction afterwards, which means the difference between them, if I subtract them, is not equal to 0. There is a difference. So here are our two hypotheses. The first and the null is that there's no difference between the satisfaction scores, and the second is that there is a difference. The difference between them is something other than 0. We're going to put this information into StatCrunch. So when we open up StatCrunch, under Stat, T-Stats is a two-sample summary. I know the sample size for each was 350, so I might as well get that in there. For the first sample, mu1, I had a mean of 7.3 and a standard deviation of 2.3. So that's 7.3 and 2.3. For the second sample, we had a mean of 7.7 and a standard deviation of 3.4. 7.7 and 3.4. Now, students get confused with the pool variances. We are not going to check that box. When we pull variances, what we can assume is that the population standard deviations are equal, and we don't want to make that assumption. So usually, actually I'm just going to say, in every example, you're not going to want to pull the variances. Just assume we don't know the population standard deviations and they're not equal. We have no idea what these population standard deviations are. So keep this unchecked. We are running the hypothesis test that there is a difference in the null, or excuse me, there's no difference in the null, and the alternative is that it's not equal to 0. When we compute, what we get is a p-value, this is what we're looking for here, a p-value of 0.0688. 0.0688 is our p-value. So the p-value is 0.0688, which means, when we go back, just making sure, good, which means this is greater than our level of significance, 0.01. Since it's greater than our level of significance, we are not going to reject. We are going to fail to reject. Fail to reject the null. In other words, we don't have evidence to reject this claim. There's no evidence to reject that the means are different, right? Or the means are the same. So what we think here, and if we attach this back to the problem and connect it back to the problem, this is kind of supporting the null hypothesis that the mean is the same before and after. That's what we're suggesting here. We can't throw that claim to the side. So we're failing to reject the null, which is telling us that this is something that we can't reject. There's no evidence to reject this claim. What I want to do now is to create a confidence interval. Now, a confidence interval for the difference, in this example we are looking at a two-tailed test. The reason I know it's two-tailed is because the alternative is not equal to, and my level of significance was 0.01, which means in each tail there's 0.005 and 0.005. So what I want to create here is a 99% confidence interval for the difference. The reason I'm going over this is because you're going to have to do this on your homework. So let's go back into Edit. We're going to create a confidence interval, and it's going to be 99. You might be saying, well, wait a second. When we did the proportion example, we went from having 0.05 as our level of significance, but then we put that in both tails and got a 90% confidence interval. The reason why is that was a one-tailed test. In this example, we're already working with a two-tailed test, which means this level of significance is already being split. So we are working with 99% in the middle here. We're already working with two tails. So let's go back, create a 99% confidence interval, and what we find is a lower limit of the differences between is almost -1, and the upper limit is approximately 0.17. We can make a conclusion here. Since zero is contained in this confidence interval, that is going to tell us we're failing to reject the null. That there is a possibility, without chance here, there's a possibility that 0 is contained in there, and we know 0 represents there is no difference. If this interval were to be completely positive, right, from a positive number in the lower limit to positive in the upper limit, then 0 would not be contained, which would suggest that there is a difference. But since 0 is contained in this interval, this is evidence to support, or evidence to warrant that we are going to not reject or fail to reject the null hypothesis.